This is a project about evaluating individual muscle oxygenation in the morning and the afternoon by using fNIRS device. fNIRS, Functional Near-Infrared Spectroscopy, is a brain imaging non-invasive technology that measures fluid oxygenation changes and detects neuronal activities by near-infrared light. I had an opportunity to use a fNIRS device called REPACE that utilize individual lactate threshold test and SMO2 muscle oxygen saturation consumption from a company named OBLab. Before this research, my personal interest had prompted me to conduct this project. My first personal interest was the experience of the cross-country team. I was a founder and the president of the cross-country team in my high school. From the experience of the marathon and running competition, I ran in the morning and afternoon before. I want to explore when the appropriate time is to run more efficient to get a good result. My second personal interest was data evaluation. For my past experience of research, I utilized many data analysis methods such as Python plotting and machine learning. I wanted to use my statistical strategy to conduct the experiment and get the data from it, and finally interpret the meanings of the result. This is my specific research methodology to plan, execute, and manage the project more effectively. The first step of the methodology is internship and basic research. I research the functions of the REPACE and know the technology in the device while I'm doing the internship. The second step is running on the drill mill in the morning and evening. It took 1 week. The third step is data organization, receiving data from the REPACE server in OBLab. It is to collect the raw data from the result of LT tests in the device. The first step is data analysis, making tables and graphs to arrange the data more clearly and interpreting the meanings of the results. The last step is to present the project and publicize this project. The technology of REPACE is based on functional near-infrared spectroscopy technology, which is called fNIRS technology. Before creating the REPACE device, OBLab previously created a device called NIRSIST, using this technology to deeply understand the brain by utilizing emitting source and light receiver to measure oxyhemoglobin and oxyhemoglobin concentration changes. Similarly, REPACE measures individual muscle oxygen saturation levels by utilizing functional near-infrared spectroscopy technology. By using a special lens, REPACE is able to measure the SMO2 rate that should be constant to reduce the muscle negative effect. It has steps in the lactate threshold test to control the oxygen saturation level on individual muscles. So what is muscle oxygen saturation and why is it important to people while they're taking exercise? Muscle oxygen saturation is an amount of oxygen in muscles by measuring the oxygen level, oxygen delivery, and oxygen consumptions in muscles. When oxygen enters the human body, it's spread throughout the body by hemoglobin in blood. In order to use muscles properly and prevent muscle injury, it is important to make SMO2 value constant. But if the person exercises more, the person will utilize muscles instead of oxygen, which can increase the amount of lactate usage than oxygen usage. As a result, it could not avoid excessive workouts that can have a negative impact on physical performance. Therefore, REPACE conducted LT tests to prescribe the exercise intensity to people. Originally, lactate threshold LT test requires blood and a long time for the result. However, REPACE can conduct LT tests without requiring blood and long time to estimate the lactate threshold level, which is indicative of fatigue level of all muscles during the workout. Also, if the change of SMO2 is constantly zero, it shows the positive performance while doing the workout. By calculating the overlapping part where oxygen saturation falls and blue lactate raises to prescribe the intensity of exercise of individuals. After the calculation, it prescribes the appropriate exercise intensity to the athletes by showing the stages. For these advantages from REPACE, I was able to conduct an experiment to compare the individual muscle condition while running on the drill mill and measure the amount of SMO2 by conducting LT tests in the morning and afternoon. The subject of the experiments was an 18-year-old male. The time took 1 week for the experiment. It required REPACE device, drill mill, cell phone, and computer to complete the experiment. The morning was 8 a.m. and the afternoon was 4 p.m. Before the experiment, I made 3 types of hypotheses. The first one is change in SMO2 on afternoon is better than change in SMO2 on morning. The second one is blood lactate on morning is higher than blood lactate on afternoon. The third one is muscle condition on afternoon is better than muscle condition on morning. These are the video clips while I'm running in morning and afternoon. These graphs shows the result of morning performance. The left graph shows the LT test stage that took place in the morning. On the other hand, the right graph shows the change of SMO2 in the morning. In the results, the major LT test stage in the morning was 5th stage and SMO2 change didn't remain 0 a lot. On the other hand, these graphs shows the result of afternoon performance. Similarly, left graph shows the LT test stage that took place in the afternoon. On the other hand, the right graph shows the change of SMO2 in the afternoon. The major LT test stage in the afternoon was 6th stage and mostly SMO2 change remained 0. This shows the comparison between the morning and afternoon performance. Specifically, in the stage reach area, the afternoon shows the average 6.44 stages, which is larger than the morning performance, which shows the 5.25 stages. Additionally, in the change in SMO2, the afternoon shows the lower change that average is negative 1.5875, than morning which average is negative 5.37. As a result, when comparing LT tests at morning and LT tests at afternoon, the stage level in the afternoon was higher than the stage level in the morning. Average of change in SMO2 in the afternoon was closer to 0 than in the morning. Average of change in SMO2 in the morning was not closer to 0 than in the afternoon. And this is the conclusion of the experiment. The amount of SMO2 was controlled more efficiently in the afternoon, because the stage was high when running at afternoon than morning. On the contrary, the stage was low when running during the morning because the more lactate was generated in the low intense exercise that shows the low efficiency when running during the morning. Those are the results and conclusion of my experiment, but I wanted to know why this phenomenon happening into my experiment. So I did some additional research and found some article called Different Effects of Heat Exposure Upon Exercise Performance in the Morning and Afternoon to explain the phenomenon happening in the experiment. It is because in the morning the people have low body temperature, which means their body delivers blood slower. But then they do exercise, the oxygen transfer rate rapidly increases. Then many difference of muscle oxygen saturation in body happens that make people's body unstable, which means it causes the low exercise efficiency. On the other hand, the afternoon, because people do the daily activities, which means they have the high body temperature and delivers blood faster. And doing the exercise that can make oxygen transfer rate rapidly increases, but comparing between the morning, it causes no many difference of muscle oxygen saturation in the body. which means it causes the high exercise efficiency. Next time, it will be better to conduct a longer time period in the experiment to show more elaborate results of the experiment. Also, in the future, I am going to compare the performance between a person who didn't practice a marathon before and a person who practiced a marathon a lot by using REPACE. To emphasize the benefits of the marathons by showing the scientific results from the lactate ratio test results. And thank you for watching this video.